Mixtures and allegations. One of the most unattended questions by students in any competitive exam. Why? Because with the other concepts, students might fail to understand the question. But here, they fail to understand the concept itself. Now, again why? Because of the randomness of learning. Well, there is not much of the concept in the mixtures and allegations. Now, you have to learn by solving the various types of questions. But you cannot pick those questions randomly to learn. There is a step-by-step strategy to select the type of a question you have to start with. So, in this series, you will be learning all the strategies about mixtures and allegations. Hi, I am Abhilash Varma. Welcome to Learn Online. Let us directly start with an example here. Now, if you have two types of rice, let's call them as R1 and R2. Now, R1 costs you 35 rupees per kg, whereas R2 costs you 50 rupees per kg. Now, suppose if I ask you, in what ratio you have to mix both the rice so that the price of the mixture, let's call it as R dash, is 45 rupees per kg. Let me make you understand the question again. You have two types of rice, let's call them R1 and R2. R1 costs you 35 rupees per kg and R2 costs you 50 rupees per kg. In what ratio these two rice must be mixed so that the mixture should cost 45 rupees per kg? Well, you have already done this in averages, because mixtures and allegations is just a combination of ratios and averages. So, if I am not wrong, you have already learned this formula in averages, which is N1 by N2 is equals to A2 minus A dash divided by A dash minus A1, where A1 is the lower price, A2 is the higher price, A dash is the mean price. Now, if I apply the same formula, I'll get the same answer. Let us check that out. So, in this case, A2 is the higher price, that is 50, minus A dash is the mean price, that is 45 rupees per kg, divided by A dash, again 45 rupees, minus A1 lower price, that is 35. So, if you solve this, you should get 50 minus 45 is 5. Divided by 45 minus 35 is 10. So, N1 by N2 is equals to 5 by 10 is nothing but 1 by 2. So, it means you have to mix both the rice in the ratio of 1:2 so that the mixture will cost you rupees 45. Well, this is a very general way of solving. Now, if you use the method of allegations, that is pictorially solving the problem, will give you the answer in a much easier way. Let me show you. So here I'll call terms as R1 and R2, which is nothing but rate 1 and rate 2, which is also nothing but average 1 and average 2. And R dash is also nothing but mean price or the price of the mixture. Now, according to the question, R1 is given as 35 rupees per kg, R2 is given as 50 rupees per kg. All you need to do is take the difference, and also R dash is 45 rupees per kg. So, you just take the difference diagonally here. When you take difference diagonally, what is the difference between 45 and 50? That is 5. And difference between 35 and 45? 10. So, what is the ratio? 1:2. Absolutely the same answer. Now, if you see why we are getting the same answer, in fact, we are representing the same formula pictorially here. How? Check this. This is nothing but R2 minus R dash, that is 5, 50 minus 45, which is also nothing but A2 minus A dash, divided by here. How did I get this? R dash minus R1, 45 minus 35, which is 10, which is A dash minus A1. So, when I represent the same formula pictorially, we can get the answer in a much beautiful way. Now, suppose if I give you a question something like this. Let's say there are two types of sugar, that is S1 and S2. Now S1 costs you 20 rupees per kg and S2 costs you 50 rupees per kg. Now my question is, in what ratio I have to mix both the sugars so that the price of the mixture is 30 rupees per kg? Well, we can solve it pictorially. We know we will take R1 and R2 and R dash. R1 is 20 rupees and R2 is 50 rupees and finally R dash is 30 rupees. Now, if you take the differences, 50 minus 30 is 20 and 30 minus 20 is 10. What is the ratio? 2:1. So that is our final answer. Now one thing you have to remember here, our S dash, that is price of the mixture, should always lie between S1 and S2. It cannot go below 20 or it cannot go beyond 50. Let us see one more example. Suppose if I say there are two types of wheat, wheat 1 and wheat 2. Now wheat 1 costs you rupees, let's say 20 rupees per kg, and wheat 2 costs you 50 rupees per kg. Now if I ask you, in what ratio we have to mix so that the price of the mixture is, let's say, let me take some 70 rupees per kg. In what ratio we have to mix both the wheats, both the two types of wheat, so that the price of the mixture is 70 rupees per kg. Now we will take R1, R2, R dash. Now what do we have with the R1? 20, R2 is 50 and R dash is 70. So let us take our differences here. 70 minus 50 is a 20 and 70 minus 20 is 50. What do we get ratio? 2:5. So we have to mix both the types of wheat in the ratio 2:5 so that we'll get the price of the mixture as rupees 70. Well, you might be very convinced with the answer, but I say this is absolutely wrong. Why? Just in the previous example, I clearly told you that the price of the mixture cannot be less than the lower price and cannot be more than the higher price. If you see wheat 1 and wheat 2 are costing only 20 and 50, how can the mixture cost more than 50 rupees, which is 70 here? Though you get some answer here, that is meaningless. So make sure in every problem, the price of the mixture always lies between your R1 and R2. Suppose if I give you a question something like this. In what ratio water must be mixed with juice costing 16 rupees per liter so that the price of the mixture is 12 rupees per liter? Well, the data what I gave you here is, we have water and we have juice and we have mixture. Now I told you price of the juice is 16 rupees per liter. When I mix both water and juice, the mixture should cost us rupees 12 per liter. In what ratio we have to mix the juice and water? Now if you represent it, R1, R2, R dash. R1 is water, R2 is juice, which is 16 rupees, and R dash is mixture, that is 12 rupees. Well, what is missing here? We don't have price of water. Did I give that? No. Well, whenever in any question, if you find water and its price is not mentioned, then always assume price of the water to be rupees 0 per liter. So in this case as well, so price of the water is 0. So now when I take the ratio, I'll get 16 minus 12, that is 4, and 12 minus 0 is 12. So 4:12 is 1:3. It means we have to mix both water and juice in the ratio of 1:3 so that mixture costs us 12 rupees per liter. Suppose if I modify our first question something like this. How many kg of sugar costing 50 rupees per kg should be mixed with 30 kg of sugar costing 35 rupees per kg so that the price of the mixture is 45 rupees per kg? Well, this is the first question where we are talking about quantity. So far we were only dealing with the prices. We never bothered about how many liters or how many kgs. But while in this question, I'm not asking the ratio. Rather, I'm asking how many kgs of type 2 sugar must be mixed with 30 kgs of type 1 sugar, right? So far the questions were only on ratios. Now the question is based on quantity. So let us see how to deal with this. Well, be it quantity or cost price, selling price, anything, first thing you must always to do is calculating the ratio. Now first let us calculate the ratio here. We have R1, R2, R dash. R1 we have 35 rupees per kg, R2 we have 50 rupees per kg, R dash we have 45 rupees per kg. Now if we take the ratio for this, we should get 50 minus 45 is 5, 45 minus 35 is 10, 5 is to 10 is 1 is to 2. So it means our S1 and S2, both the types of sugars must be mixed in the ratio 1 is to 2. This was very first question what we have earlier handled already. But here I am not asking about the ratio, rather how many kgs of type 2 sugar must be added for 30 kgs of sugar. Now what do you understand by this ratio 1 is to 2? It means if you have 1 kg of first type of sugar, then there must be 2 kgs of second type of sugar. But according to the question, we have 30 kgs of first type of sugar. So for 1 kg, we should need 2 kgs from type 2. Then for 30 kgs, we need 60 kg of type 2, and that has to be our final answer. So even to calculate the quantity, first step you always need to perform is calculating the ratio. Now again, let me modify the same question little more. So what I do is, in what ratio 2 types of sugar costing 35 rupees per kg and 50 rupees per kg should be mixed, so that by selling the mixture at rupees 54 rupees per kg, you can make a profit of 20%. Well, look at the change in the question here. We spoke about only ratio. We spoke about quantity. Now again I'm asking in what ratio these two must be mixed, so that by selling the mixture at 50 rupees per kg, you can make a profit of 20%. Well, in the same question, now I have combined profit and loss here. Now, you can take your R1, R2, R dash. Now R1 is 35, R2 is 50, and R dash is 54. No, do not do that mistake. This is the selling price. If you sell at 54 rupees per kg, you should get 20%. This is not our R dash. R dash is the cost price of the mixture. So first step you need to do is calculate the cost price of the mixture. Well, you have selling price, you have profit percent. How do we calculate cost price? Recall, go back to profit and loss. To calculate cost price, we always use a relationship. Now, 20% profit means the selling price must be 20% more than the cost price. So, what can I do? Selling price is equals to 20% more means 120% of cost price. So, SP is 54. 120 means 120 by 100, which is 6 by 5 of CP. 6 ones are 6 nines, 5 nines are 45. So what do we get? Our cost price as 45 rupees. So this is the price of the mixture. So now we got the price of the mixture. R dash will apply this here, 45. So what happens? I'll take the difference here. 50 minus 45 is 5. 45 minus 35 is a 10. So 5 is to 10 is what? 1 is to 2. Again, we have to mix both the ratio, both the sugars in the ratio of 1 is to 2, so that we can make a profit of 20% even when you sell the mixture at rupees 54 per kg. Now, again, look at the pattern. We dealt with ratio. We dealt with quantity. Now again coming back to ratio, when profit and loss is involved, can I convert it into question based on quantity when profit and loss is involved? Yes, it's a simple thing. Let's say if I have this one as some 40 kgs, S1 we are having 40 kgs and S2 is, let me say, Yeah, this is the question mark. How will I make that question? How many kg of type 2 sugar should be mixed with 40 kg of type 1 sugar so that by selling the mixture at rupees 54, we can make a profit of 20%. Any changes? Nothing much. Instead of just ratio, here I am asking the quantity. So first step is same, absolutely. You calculate the cost price and then you calculate the ratio. Once you get the ratio, work on the quantity. You know that if there are 40 kgs here, how many kgs we need to add. Now, with the ratio we can tell if I have 1 kg of type 1, we should have 2 kg of type 2. Then, according to the question, type 1 is 40 kg. Then what should be type 2? Obviously 80 kg. So like this, you can modify the same question in different ways. Like he can ask ratio, he can ask quantity, he can ask profit and loss. In the profit and loss, again he can ask only the ratio or only the quantity. Now let us see another type of a question where we have 50 liters of milk in a can. From that, 10 liters is removed and replaced with 10 liters of water. Now again, if the same procedure is repeated one more time, what is the amount of milk left in the container or a can? I am repeating the question. There is a container or a can with 50 liters of milk in it initially. From that, 10 liters of milk is removed and then 10 liters of water is added. Now the same step is repeated one more time. It means again another 10 liters from this is removed. Again 10 liters water will be added. So what is the amount of the milk left in the container? Now if you think 10 plus 10, 20 liters milk is removed and 30 liters milk is left over. No, you are absolutely wrong. Why? Let me explain that to you. Now, first let us go stepwise initially. Now in the first time, 10 liters milk is removed and 10 liters water is added. What happens? In the container, we will have 10 liters milk is removed out of 50 liters means we will be having 40 liters of milk. Because 10 liters water is added, we will have 10 liters water. Right? Now, again, when you remove 10 liters from this, and if you add 10 liters water to this. Now this time, when you remove 10 liters from this, do you get only milk in the 10 liters? No. This 10 liter will have both milk and water. Now how much amount of milk will be there and how much amount of water will be there? Now in the main container, we have 40 liters of milk and 10 liters of water. So, milk and water, the ratio in this, that is 40:10, which is nothing but 4:1, right? So in the container, if milk and water are in the ratio of 4:1, if you take 10 liters from that, in the 10 liters also, we will have milk and water in the ratio 4:1. So let us see how much milk is removed and how much water is removed. So if I take milk, milk is 4 parts out of total 5 parts of 10 liters. So what do we get? 8 liters. So in this 8 liters milk is removed. Out of 10 liters, 8 liters is milk means then water should be 2 liters. Now, check this. Originally, after the first step, here we had 40 liters milk. When I removed 10 liters, 8 liters milk came out from this. Out of 40, if we removed 8 liters, then the remaining milk will be 32 liters. Now, out of 10 liters water, 2 liters is gone out in this. So, we will be having only 8 liters, but we are adding again 10 liters. So, that should be 18 liters of water. And this is milk. Now what was my question? How many liters of the milk will be left in the container after the 2 steps? The answer is 32 liters. Agree? Now well, this is a very general way of solving. Now what if I ask you after 3 steps? Are you going to go for one more step? No, it's going to be pretty lengthy. So what we have to do is, instead of doing this, if you can see what is the concept lying inside this, you can solve the same question within 10 seconds. Now let us see what else can be done with this. See, every time you're removing how many liters from the container? 10 liters. You're removing 10 liters out of 50 liters, which is 1 by 5. That is nothing but 20%. Agree? Now, if you see, originally milk was 50 liters. Now you removed 20% of it. 10% of 50 is 5. 20% is 10. I'll remove 10. What do I get? 40. If you see, we are left with 40 here. Again, another step. Again 20%, because again you are removing 10 liters from total 50 liters. So again 20% you are reducing it. So what happens? So 20% of 40 this time. 10% is 4. 20% is 8. So if I subtract 8 from this, what do I get? 32 liters. That is absolutely same answer. Now you can identify which concept is this successive percentage of percentages. If you know that the question is based on successive percentage, the question can be solved within 10 seconds. What if we'll ask for one more step? Let's try that as well. If we ask for to do it for one more time, again we shall remove 20%. 10% is 3.2. 20% will be 6.4. Let us subtract 6.4 from this. So what do we get? 35.6 liters. Finally. So instead of 2 steps, if we talks about 3 steps, final amount of the milk left in the container. So I'm sorry, this is 25.6 liters. So doesn't matter any number of steps. If you just can identify the question is based on successive percentage, you can just successively reduce the same 20%. Now, will it be 20% all time? No. I can modify the same question in this way. For example, let's say there is 80 liters of milk and you remove 8 liters of it and replace with 8 liters of water. Now what is happening? Let us try the same one. You are removing how many liters? 8 liters out of 80, which is 1 by 10, which is nothing but 10%. So just apply the successive percent. Originally 80 liters, decrease it by 10%. 10% of 80 is 8. So 72 liters will be left after the first step. So after the second step, again you remove 10%. What is 10% of it? 7.2. Decrease 7.2. What do we get? 64.8. This is after the second step. Milk left in the container after the second step. If you ask one more, let's go for that as well. Again remove 10%. What is 10% of 64.8? That is 6.48. Now let us remove this. This should give us 58 point. That should be 32. So final milk left after the third step must be 58.32. Now what if we ask what is the amount of the water left in the container after the third step? Well, total 80 liters will always be there in the container, out of which milk is 58.32. So remaining 21.68 should be water. So this is how the question can be asked based on the container and removing some liquids out of it. To watch more free videos, download our LOL application from Play Stores. If you are benefited by these videos, please like and share our videos, and also do not forget to subscribe to our YouTube channel so that you don't miss any of our new videos that we upload regularly. If you have any queries or suggestions, please drop them in the comment section below. Also, if you want to reach out to me or any of my team members, you can always do that through any of the social media platforms, and the links of which are already provided in the description below.